Okay, topic B is on set notation. Before we can talk about set notation, we need to know what an actual set is. And a set is just basically a collection of elements. Okay, so for example, when you solve an equation like this, x plus 5 times x plus 4 equals 0, and we say our answers are -5 and -4, that means that this is my set of answers that will possibly work. Here's my collection of elements in my solution set, okay? But that's just so you can see that you already have seen a set before. Now there's something called set builder notation, and set builder notation is going to be written out as follows. You always start off with your brackets, okay? And then you have whatever variable you have. So in this example right here, my variable is x. So if I write it out like this means that x is going to be my variable, and this line right here means I'm going to define it as follows. This reads as x is a value such that, this means such that, right here, x is an element of the real. So this means element, this means real numbers. Okay? And x is greater than or equal to 4. Okay, that's what this first one is saying. Okay, the second one right here is saying that x is being defined such that x is an element of all the positive integers and x is less than or equal to 12. Okay, now set builder notation branches off into either roster notation or interval notation. Now, if you hear the word roster, you probably are familiar with roster, like a class roster or a sports roster. It's just a list of items, okay? So it lists all the elements in a set. Now, for a list of elements in roster notation, it means you're able to actually list out the elements, right? So for example, I can list out 1, 2, 3, 4, 5, because it's just a list, right? But that only works because these are integers. Now for interval notation, that means that generally when you have interval notation, it's impossible to list out all of the elements. So if I were to list out everything between 1 to 5, it would be impossible because there's so many decimals and numbers in between that it's impossible to list it out. There's infinite possibilities, right? Like I can't just say 1, 2, 3, 4, 5 because I could include 1.5, I could include 1.01, I could include 1.000000001. It's endless, right? So for interval notation, you should be familiar with that because you did learn that in the Common Core class. Now, just so that you guys know, if you have less than or equal to or greater than or equal to in your interval notation, you're going to always use a closed bracket, and we'll talk about that a little bit more in detail in a minute. And then if you have less than or greater than, you just use an open bracket. Okay, and just so that you guys know, these are closed, and then these are open. So if I wanted to include all the numbers between 1 to 5, including 1 and 5, then my interval would be 1, 5. Just like that, and hopefully that should be familiar to you. Okay, so an example of something that's listed out in roster notation, remember you are able to list it all out, is in this example right here. X is an element of all the positive integers and x is less than or equal to 12. So I can actually list out all the possibilities. X has to be a positive integer. So the first positive integer that I have that exists is 1, and that is less than 12. And I would keep going until I get to my maximum value, which is 12, including 12. So in roster notation, I listed out all the possibilities. I cannot say that my answer is between 1 to 12 like this in interval notation, because that means that like 7.4 can work, for example, or 9.3. But it doesn't work because it has to be an integer. So that's why this is in roster notation, okay? Now this example right here, x is an element of all real, so all possible numbers that we know in this class that exist, x could be any one of those numbers as long as it's bigger than or equal to 4. So if I were to graph it out on a number line, I would have 4 right here, 3 right here, 5 right there. I can put a closed circle right here, and it would be every single possible value after 4, including 4, right? If I were to draw this out on the number line, this answer right here on the number line, here's 1, 2, 3, 4. Sorry, it's a little messy. I would only have a dot here and then a dot here. Notice how there's space in between each value, and that's why I can list it out. Here, I can't just list out 4, 5, 6, 7 because an answer could be like 4.3, 4.005, okay? So what I'm going to do is I'm going to say that my answer starts at 4, ends at infinity, okay? But it includes 4, and then it will never ever reach infinity. So it's an open circle there, okay? So let's write this out. In roster notation, you've got this example right here. This is roster notation because you were able to list out all the elements. Now, set builder notation always starts as defining our variable. So we'll call our variable x. You can call it any letter you want. So x is going to be something that's defined as follows. Remember, this line defines it. And I'm going to say that x is an element of, what kind of numbers are these? These are integers, okay? So x is an element of the integers, and x is smaller than -1. It's -1 down, right? So x is less than or equal to -1, all right? I could also say x is less than 0 if I wanted to, because -1 is the first number that's less than 0. Either one of those is fine, okay? And then I can't write it out in interval notation because interval notation means everything after negative, or before -1, excuse me, including all the possible decimals, which is not in my set, all right? All right, so now this one right here, x is an element of the integers and x is less than 9. Am I able to list out all the possible values? The first number that would work would be 8. All right, now do I have any numbers between 8 and 7 that will work? No, because x is an integer, which means I can list out my values, which means I can write it in roster notation. So 8, 7, 6, so on and so forth. All right, because it's not every single number between, or every single possible value that's less than 9, there is no interval notation. Okay, now in this example right here, x is being defined so that it's between -4 and +2. This means that it can be any value between -4 and +2, which means it's impossible for me to list it out, so there is no roster notation. In interval notation, this means that it starts at -4, it ends at 2, it includes -4, but it does not include 2. Okay? All right, and then lastly, -5 to infinity. This means every single possibility between -5 and infinity, which means I cannot list it out, so I cannot write it in roster notation. So then in set builder notation, I'm going to say x is defined as x is greater than or equal to -5 because it starts at -5 and it goes on to infinity.